Hello everyone, welcome all to our platform of Educator's Mind. So we are going to continue the same session. So this is just an introductory class to introduce you to the basic principles about physics that you will be studying throughout the next 2 years at least. Okay. So let us start with this. So what is the topic for today? So today we are going to discuss scope and excitement of physics. So everyone studies physics, right? Everyone studies physics, those who are particularly doing their 11th, 12th, or those who are preparing for J, NEET. Now what is the scope? What is the broad application point of view if you see where you are going to apply it in future, or the scientists who are working on it, those who are developing the theories, what is the scope of this? So let us understand this. So one thing is called macroscopic domain and another is called a microscopic domain. So where can you apply physics? Physics are applicable to all the physical phenomena, the concepts that you study, but basically there are two domains of application. You can see one is the macroscopic domain, big like for example planets or celestial bodies, different solar systems, right, galaxies, at big level of measurement that you do. For example, any phenomena that is happening due to macroscopic level, at macroscopic level, for example, the motion of the planets around the sun, around the in our solar system, how the planets are revolving around the sun. So these laws are governed by particular law, set of laws like gravitational Kepler's law that we will also study in this also chapters. Okay, next chapters. So laws of gravitations like the planetary laws, Kepler's law, first law, second law, third law, how the planets are moving around this sun in an elliptical path, what is the relationship between the time period and the axis, length, and all these things. Okay, so when we talk about a bigger picture, the physics can be applied to that level also. Okay, that level also. So it's not that physics is applied only to the atoms and molecules, it is applied to that level, extreme level, and the other extreme is the microscopic domain. So first of all, we are going to understand in more detail little bit about macroscopic domain, then we will go to the other microscopic domain. So what is this macroscopic domain? So as I told, it's a bigger picture that is happening in nature. So it includes phenomena at the laboratory, the terrestrial and astronomical scale. So bigger picture doesn't mean only at very large planetary scale, but it is also at our level in our laboratory, the nature that we see. This is all all is macroscopic only. Of course there scale difference is there, but these are all classified as macroscopic domain where the physics or the laws of physics are valid. Okay, now that is called, for example, one very important category in this is called classical physics. Classical physics is also termed as it's Newtonian physics. So everything is based on Newton's laws of gravitation, laws of motion given by Newton, first law, second law, third law, all these things. The basic foundation of mechanics is completely based on Newton's laws. So mechanics also is a part of classical physics. Electrodynamics is also part of classical physics. Optics is also part of that. Thermodynamics is part of this. So these physics I am going to explain you little bit. Okay, so mechanics means, of course, briefly, mechanics means you study about the object's motion, cause of motion, and if it is moving, how the velocity is there, the speed is there, is it accelerating or not. All these things you will be studying also in the, I think, second chapter onwards. You will be studying all these things. Okay, then electrodynamics, of course, the dynamics of the charges, how the charge, okay, current, there will be current flowing, okay, and there will be, let us say, the charges, the properties associated with that, okay, those things. Then optics, we know that the physics behind the light, how the light is working. For example, I can see you, you can see me, you can see everything around, because light is getting reflected, reaching to our eyes. So the process or the phenomena of refraction, all these things. So of course optics are also classified into two. One is called ray optics, another is called wave optics, that you will study in class 12 of course. But here in optics means it includes both the phenomena associated with light, okay. Then thermodynamics, of course thermodynamics, you study how the heat can be converted into work, the various thermodynamic process like isothermal process. You are giving heat to a body at a constant temperature, then how it behaves, the laws related with thermodynamics like the first law, second law, and all these, okay. So Carnot cycle, Carnot engine, so many things, all these are part of classical physics, which comes under the category of macroscopic domain. So you study the bigger picture, okay, about the world, the phenomena that is happening in practical life, okay. Then the second picture is microscopic. This is where the application of the physics extends itself from lower extreme to upper extreme. Okay, so what is microscopic domain? It includes phenomena at atomic, molecular, and nuclear levels. This means at, if you go at very small level, for example the atomic level, the molecular level, the nuclear level, how the physics work there. So there is a completely different kind of physics. We call that as quantum physics. Okay, so quantum physics completely different. It's a completely different branch of physics where you deal with very small particles like electrons and protons, nucleus, where there is lot of uncertainty in their positions as well as the momentum. So all these things behavior when you study at very small level, that is called microscopic domain. Okay, so why do we study that? Because based on that we can explain the bigger level, right? That same principle that we studied in the last class, we are going to use both phenomena, this unification and reduction, right? So macroscopic means you can say unification, you are unifying everything and trying to explain that, and macroscopic means you are going to very small level and trying to explain that. That is called reduction process, okay. So hope you liked our session for today's class, okay. So similarly we will be continuing the same session, okay. So hope that you all try to connect with us. So this is our platform, so you please connect with us at Educators website, okay. We have our Facebook platform, LinkedIn, Twitter and Instagram. So thank you so much for your attention. We'll see in the next class, students. Bye bye all.